Previously, on gas laws, you saw a chart similar to this, and we actually had the results filled in, but since that was a while ago, we're going to refresh your memory. Changing pressure, volume, and temperature at constant number of moles. Remember, PV and T are pressure, volume, and temperature. So in our first instance here, we're going to change pressure and volume. We're going to keep temperature constant, so that's not a factor. And as we talked about, if I increase the pressure on something and I squeeze it, we're going to assume it's going to get smaller, so the volume would decrease. And again, if I release the pressure, the volume should increase. So our result, or our relationship, which is what we're really looking for, is that as pressure increases, volume decreases. And vice versa is true. As pressure decreases, volume increases. So you can look at it either way. Now, what happens if I change volume and temperature but keep pressure constant? Okay, so the example I used in class was taking one of those Mylar silver balloons outside on a day like today that's really cold, so you get it filled in the store, it's all nice and warm, it's all full, and you take it outside, and what happens? It deflates. Or any helium balloon that you buy in the store. You take it outside on a really cold winter day, and the balloon gets smaller. So if our temperature decreases, the volume of our balloon decreases, and vice versa. Once you take that balloon back into like a warm house, the volume is going to increase again. Alright, and then last change we're going to talk about is changing pressure and temperature and the relationship between those two. We're going to keep volume constant. So we also talked about temperature being kinetic energy and pressure being the collisions against the walls of the container. Okay, so let's take something where the volume is going to stay constant, our pressure is going to increase, we're going to have more collisions is going to equal higher kinetic energy, which is a higher temperature. So if we increase the pressure on something, we're going to increase the temperature on it. Or if we increase the temperature, the pressure is going to get bigger because there are more collisions. So either way you look at it. And again, all of these results here, all of these results can be the opposite. So if pressure decreases, volume is going to increase. Here, if temperature increases, volume will increase. And here, if pressure decreases, temperature decreases. Alright, we're going to do some problems in our next session, but here's some problems involving, or here's the steps for problems involving changing temperature, pressure, and volume at a constant number of moles. Step 1. You have to identify what you're changing. So what's changing at constant number of moles? Step 2, remember, always use Kelvin temperature. Always use Kelvin temperature, and that's so that we avoid negative numbers and 0. So the conversion is you take your degrees Celsius and you're going to add 273 to it. And that will give you your answer in kelvins. That should be a capital K. There you go. Step 3, identify the initial and final conditions. This is one of the most important steps. You have to know what you start with and you have to know what you end with. Alright, and step 4. Use the model that I'm going to show you to multiply by a factor. So you don't have to memorize anything, you just have to use common sense and remember the chart of what happens when you do something to another because it's a relationship. So use a model to multiply by a factor. So we're going to use just multiplying by a fraction. Okay, in the next set we're going to actually do some problems. So that's a basic introduction of the relationships and how to solve problems. Now let's go do some.